Myself is Prabhakar. For BSc Electronics, first semester, University of Mysore. This is the third session. In the last session, I had explained the mesh analysis method. In this session, I will explain the nodal analysis method. This is the second method is used for solving any electrical network. First, we must know about the definition of the node. Node is a point where the two or many elements meet at a point. That means many elements are connected. Two or more elements are connected. Nodal analysis is the application of the KCL. In the first session, I had explained the KCL. KCL means Kirchhoff current law. It states that the sum of currents flowing towards the junction, that means junction means node, is equals to the sum of current flowing away from the junction. Next, to analyze the DC circuit by nodal analysis method, first we must identify the node. You know the node is a point where the two or many elements meet at a point. That means from circuit, say E1, E2 and E0 are the nodes. That means the potential of the node is E1, the potential of the node is E2, the potential of the node is E0. One node we have to take as a reference node. That means in this I will take the potential of the node is 0, E0. So E1 and E2 are the significant node. So we have to calculate the voltage of E1 and E2 nodes. Once the voltage E1 and E2 knows, we can calculate all the branch currents. In the circuit, let I1, I2, I3, I4, I5 are the branch currents of respective elements. Let E1 and E2 are the voltages at the node 1 and 2 respectively. By applying KCL to the node 1, I1 equals I2 plus I3. Node 1 means E1 at the node E1. I1 equals I2 plus I3. Based on the direction of the current, the potential difference between the 2 points V1 and I1 the current I1, in the current I1, the potential difference between the 2 points, that means V1 and I1, to the total resistance R1. That means V1 minus I1 divided by R1. Depending upon the direction of currents, starting point, that means V1, and ending point is E1. That means V1 is a higher potential when compared to the E1. Similarly, for I2, E1 is the starting point and E0 is the ending point. So E1 minus E0, E0 means E0 equals to 0 divided by R2. Similarly, for I3, E1 is the starting point and E2 is the ending point. That means because of the direction of current is from E1 to E2. That means E1 minus E2 divided by R3. So E1 is higher potential when compared to E2. By solving, we get equation 1. Next, by applying the KCL to the node 2, to the node 2 means I4 equals I3 plus I5. That means I4 is going away from the junction node E2. The current I4 is going away from the junction E2. The I3 and I5 is flowing, the current flowing, there is these two currents flowing towards the E2, junction E2. In the I4, E0 minus E0, E2 minus E0. That means it depends upon the direction of the current. E2 minus E0 divided by R4. E2 minus E0 means E0 means E0 means it's a 0 volts. E2 minus 0 divided by R4. The same thing for I3 also. E1 minus E2 divided by R3. Next, for I5, V2, see here, the direction of the current, depending upon the direction of the current, V2 minus E2 divided by R5. By solving, we will get the equation 2. Solve the equations, KCL equations, either by elimination method or Cramer's rule to find the voltage between the nodes in an electrical circuit in terms of branch currents method. Next, problems on nodal analysis method. Calculate the currents in different branches of the following network by node voltage method. Next, the given circuit. In the given circuit, let I1, I2, I3, I4, I5 are the currents, branch currents at respective elements. Let E1 and E2 are the voltages at the node 1 and 2 respectively. By applying the KCL to the node 1, I1 equals to I2 plus I3. The same thing, 20 minus E1, in the depending of the direction of the current I1, 20 minus E1 divided by 1 ohm, E1 minus E2, E1 minus E0 divided by 2 plus E1 minus E2, that means I3 equals E1 minus E2, E1 minus E2 divided by 2 ohm. Therefore, by solving, you will get 40 equals 4E1 minus E2. By applying the KCL to the node 2, I4 equals I3 plus I5. That means I4 equals E1 minus 1, E1 divided by 1, that's equals to, next I3 equals E1 minus E2 divided by 2 plus I5 equals 1 minus E2 divided by 3. It is dependent upon the direction of the current. Next, by solving this equation, we will get equation 2. These two equations can be put in the matrix form, that means can be written in the matrix form as, in this we have the left hand side of the system with the coefficient matrix and the right hand side of the system with the answer values. That means in this we have the left hand side of the system with the coefficient matrix means the coefficient of E1 and the coefficient of E2, and the right hand side of the with the answer value means 40 and 2. Next, delta be the determinant of the coefficient matrix of the above system. Next, delta E1 be the determinant of the matrix formed by replacing the first column values of the coefficient matrix with the answer column values. That means first column values means, in the determinant 4 minus 3 minus 1, 11. The first column value, that means 4 minus 3 is replaced by the answer column values 42. The next, delta 2 be the determinant of the matrix formed by replacing the second column values of the coefficient matrix with the answer column values. That means the second column values means in the determinant, delta, -1 and 11, that is replaced by the answer column values is 42. Next, we have to calculate E1 and D2 nodes by the equation E1 equals to delta E1 divided by delta and E2 equals delta E2 divided by delta. In the delta, the determinant of the given matrix 4 into 11, 11 fours are 44 minus 3, minus 7 to minus plus 3 ones are 3, 44 minus 3, that's equals to 41. In the delta E1, the determinant of the given matrix is 40 into 11, that means 440 minus of minus 2, that means plus 2. 440 plus 2, that's equals to 442 volts. Next, in the delta E2, the determinant of the given matrix is 4 2s are 8 minus of, that means 40 into 3, that is 120. 8 plus 120, that's equals to 128 volts. And next, in the calculating E1, you know the E1 equals to delta E1 divided by delta. So you know the delta E1 value 442 volts. 442 divided by delta equals to 41, that's equals to 10.78 volts. And E2 equals delta E2 divided by delta. You know the delta E2 value 128 volts divided by delta 41. So 128 divided by 41, that's equals to 3.12 volts. Once the voltage E1 and E2 knows, we can calculate all the branch currents. That means I1, I2, I3, I4 and I5. So I1 equals, I1 equals 20 minus E1 divided by 1. That means it is dependent upon the direction of the current. That means the 20 volts is higher potential when compared to the E1. So 20 minus E1 divided by total resistance 1. 20 minus, the value of E1 10.78 divided by 1, that's equals to 9.22 amps. The same thing I2 equals to E1 divided by E1 divided by 2. So E1 minus E0. But E0 equals to E0. E0 equals to 0 volts. It is a reference voltage. So E1 divided by E2, E1 divided by 2, that's equals to 10.78 divided by 2, that's equals to 5.39 amp. The same thing I3 equals to E1 minus E2 divided by 2, 10.78 minus 3.12 divided by 2, that's equals 3.83 amp. The same thing I4 equals to E2, that's equals to 3.142 amp. I5 equals to 1 minus E2 divided by 3, 1 minus 3.12 divided by 3, that's equals to 0.7 amp. Thank you.